when you're a kid.
I mean, they have samurai swords and they cut a fruit and whatever. He sliced open his arm with his sword, just getting it out of the sheath one day. I was like, this. I didn't want you guys to have swords. I was like, well, what are you doing?
For the family version.
That is correct.
Thank you.
All right, as for today. So we've been graphing one line at a time, all right? Now we are going to two lines. All right, so you count Sesame Street. On the first day of Christmas. One, that's one day. All right, so, sorry. I was like, I had a flashback. So, with multiple lines, the idea is that you can find how they're related. The most common by far, all right, is econ supply and demand curves, right? You have supply and demand curves, right? And that point where they cross, right, where supply meets demand. Does anyone know what that's called? It does start with an E. If two things are equilibrium point, all right? The equilibrium point. All right, equilibrium, AKA equal, right? So the other big question we're gonna be interested in, all right, are they parallel or perpendicular? And where is that point they intersect? Again, in supply and demand curves called the equilibrium point. So the method that we investigate the most is what's known as the intersection method. We solve both equations, y equals mx plus b, and then set the two equal to each other, right? And we find it. You can also plot and verify where they cross. The point is to do this both graphically and algebraically, because if they don't cross exactly on a perfect point, right? That's where we need the algebra, right? If it's not clear in your graph. So let's look at an example here. I want to find the intersection point, all right, for these two equations. So we're going to set the equations equal. Basically, set y equal to y. All right, so I have y equals 5x plus 2 and y equals negative 3x plus 10. That means 5x plus 2 equals negative 3x plus 10. And I have some relatively simple algebra to do. X is to one side, numbers to the other. All right, and then again, the big part, plus 2 minus 2, negative 3x plus 3x. What happens on those ones? Cancel. It's super important what you do to one side, you do to the other, so you see the cancellation. I know, I see it a lot. People get kind of lazy and just do one single step. That's when the mistakes happen. So make sure I'm writing it out every time. -2 to both sides, left and right side of the equality, plus 3x to the left and right side of the equality. Again, everything we talk about in here, you have seen this all before. 100% guaranteed impossible to graduate high school, all right, or be in high school and not have seen this, all right? Our point is knock off the rust, all right, polish our execution. All right, so 8x equals 8. Oh, look at this, how beautiful, how nice the numbers worked out. X equals 1. Now remember, we are in 2 dimensions. So that is just x equals 1. How do I find the y coordinate? Plug it back in. So plug x equals 1 into 1, or better yet, both equations. I plug it into both equations because that kind of verifies that I had it correct. Y equals 5 times 1 plus 2. And y equals -3 times 1 plus 10. So that right there, that gets 7, -3 times 1 plus 10. Oh, look, 7. So they intersect. At the point, again, always point pair, 1, 7. Everything we do, right, is point pair notation. That's why, right, when we talk about our y-intercept, right? So for this first one, all right, let's do this one in red. We'll do this one in blue. All right, so for the line in blue, what's the y-intercept?
0,2.
0,2. Point pair, because they intersect at the point 1, 7. We need both pieces. All right, every time. This is a 2-dimensional graph. Fun expansion here. In what dimension do we exist? Dimensions of space are 3. There's one more dimension. Huh? We exist in 4 dimensions. 3 dimensions of space. And what is occurring tick by tick? Time. We exist in 4 dimensions. All right. Fancy fun fact.
But do we exist?
It's all a simulation.
That's real.
It's all a simulation.
It's all a simulation.
All right, so my first line, the point 0,2. And then, and again, just to practice here, y-intercept on this guy was 0.02. What's the slope?
5/1.
5/1. 5 is correct, right? We just like to write it as a fraction. For the other one, what's the y-intercept for my red line?
0,10.
0,10. And what's the slope here?
-3/1.
-3/1. Again, technically -3 is correct, but why do we like to write it as a fraction? Easier to graph because what's our little phrase?
Rise over run.
Rise over the run. Okay, so 5/1, 1, 2, 3, 4, 5/1. Other way, 1, 2, 3, 4, 5/1. And the other one, 0,10, which is right there, and -3/1. And we can clearly see, again, this is nice enough where we can do this both algebraically and graphically. I can see that my graph corresponds to what we solved with our algebra, which is definitely what we want. You want them to confirm each other because then, right, we know we're correct. If I solved it one way algebraically and got something different on the graph, all right, I know I made a mistake.
How'd you get that? Oh, negative.
Oh, yes, the red line has a negative slope. It's going down. The blue line, right, has a positive slope. It was going up. So quick logic checks to make sure your lines are doing what you think they should do, all right? Super fast, something to confirm. We okay with that? All right, nice, beautiful lines, huh? Again, no, I don't care about making mine straight either. I was like, the points indicate, all right, what the line should look like. That's why I like to draw lots of points. And again, I already saw it a little bit on the activity. Way too much. I still see this. When you only have 2 points and your line looks like that, no, junk. Okay? Draw minimum 3 points, minimum. All right? Okay, parallel and perpendicular lines. With parallel and perpendicular, this is about how the slopes react. So if 2 lines are parallel, they have the same slope, right? That means they go on forever and never touch. Perpendicular lines have inverse reciprocal slopes. So rise over 1, if it's b over a, the perpendicular line is negative a over b. So exact opposites and swap the sign. Also, so it doesn't say it when you multiply them, they become -1. Perpendicular, that means they cross at what angle?
90 degrees.
90 degrees. So perpendicular lines have a beautiful 90-degree angle between them. So we can identify by knowing something is perpendicular, or parallel, I can identify that line, right? This is a big one where you can't just make up the graph here, all right? We can't do graphing to confirm it. This one, we need the algebra. The algebra leads the way on this. So given a line, all right, and a point, I want to find the equation that passes through the given point and is parallel to the given line. So if I have my equation here, and I'm told it's parallel, and parallel lines have the same slope, that means I need to identify the slope of this line. How do I do that? Solve it for y equals. So let's subtract 3x from both sides. And divide by -2. That gets me my equation, right, in our favorite form, y equals mx plus b of the first line. Then the parallel line. The parallel slope will be exactly the same. So what's the slope of the parallel line?
3 over 2, 3 over
3 over 2, exactly the slope of the first line. So now notice what we have. I have a slope and a point. What form of a line could I use here?
point slope form.
Point slope form, all right? By definition, just to refresh, y minus the exact form, point slope. So, all right, I pick my point, which is this guy, which is x1 comma y1, right? So x1 is the -3, all right? Y1 is 5. I can plug that in. So this becomes y minus
5.
5 equals
3/2.
3/2 x minus -3, very important. The biggest mistake with point slope is dropping your negatives, right? Because it already has, this is the equation. It already has negatives embedded in it. So you want to make sure that you put in -3, it becomes minus minus, and of course, x minus -3 is actually
+3.
x plus 3. All right, although perfectly fine to leave it in that form since all we're doing, all right? It just said find the equation of a line. Did it say find y equals mx plus b? No. That is a perfectly valid equation of the line. Also, we're not graphing, so I was like, might as well stop when I have my work done. Knowing where to stop saves you time as well, right? Now, I can, and maybe on the next one, we'll solve it all the way, all right? But knowing where to pause, just as important as anything else. Okay, find the equation of the line that passes through the given point and is perpendicular to the given line. So the original slope, right, was 3/2.
-2/3.
So the perpendicular slope is negative reciprocal. Negative 2/3. All right, and just to write this again, can't write this too many times because this is the one that people are least familiar with. Y equals mx plus b, everyone seems to remember just like that. All right, point slope form tends to not be as memorable. All right, we have the exact same point though. Y minus 5 equals -2/3 x minus -3. Now, be aware, I could stop right there. But the other nice thing about point slope is that you can continue this into a slope intercept. So I don't need to start over if I wanted to find my slope intercept form of a line. I simply continue to solve this. So I'm gonna simplify that down because be aware, once again, it said find the equation of the line. We're done right there. Like I could stop right there. That is the end. All right. However, if I want to do just a little bit more, y minus 5 equals -2/3 x plus 3. And then in order to continue to simplify, what do I need to do?
Oh, wait.
Rainbow. Rainbow, yeah, FY, all right. Big note for the first quiz. If I see people messing up the rainbow or not doing the rainbow, we are rainbowing all the way down the hall and back. All right, because it is the biggest, crucialest topic, all right, that we covered these first 2 chapters. Rainbow is everywhere. When I rainbow, just multiply 2/3 in? No. What do we multiply in?
-2/3.
-2/3. All right, remember the sign goes with the rainbow. Now, if it's positive, that's easy. It's the negatives that everyone drops. So make sure, keep that negative there. And then, I could write this out slower, but -2/3 times 3, what does that become?
-2.
-2, right? Because remember, that's just 3/1, all right? So that's quick math right there. That's what we like to see. And then last step, add 5 to both sides. And I found the slope intercept form from the point slope form. So the point slope form is really, really nice because, all right, we incorporate both the point, the slope, and then it converts to slope intercept anyway. So we saw both forms of a line, all right, just by kind of simplifying what we already had. Now, last time we went through and I showed you how to do it backwards, find the B and then plug it back in. But if you always start at point slope, you really have both forms of the line there with just a couple more steps. All right, let's find the intersection of the two graphs here. Identify if the graphs are parallel, perpendicular, or neither, and justify. So the justification here, all right, needs a little bit more, and it always just comes down to the slope. Way too often, I see people's justifies, well, they're parallel, I see it, all right? Not enough justification, okay? So we want to make sure we are thorough there. And basically, when we talk about justify, this should always be reference the slopes. All right, because the slopes are what identify if something is perpendicular or parallel. Now, most graphs, are they perpendicular, parallel, or neither? Neither. Perpendicular and parallel are just special cases, just like, you know, our vertical and horizontal lines. Most graphs, right, are positive or negative sloped. Occasionally, we have the other ones. So the neither is the vast majority of categories. Okay, so for our graph Y1, okay, that guy's basically done. We can actually just go straight to the graph with that guy. Okay, 3x minus 5, so 0, -5. And then what's the slope of our blue line?
3/1.
3/1. All right, so blue line, pretty straightforward, not much to do there. The red line, can I just go to the graph here?
No.
No, what do we need to do? Specifically? Rainbow, all right? Again, rainbow is everywhere. Take that 3, I need to rainbow that guy in. And then, yes, simplify, one little step of simplification here, not too much going on. And I should be able to graph this guy. -2, 0, -2. Slope of 3/1. Now, by looking at it and by examining the slopes, what kind of lines are these? Parallel, because. Okay, that's the definition of parallel, and I'm glad you brought that up, because that's the justification everyone always gives. That's what parallel means, they never touch.
Because they have the same slope.
They have the same slope, right? That's the justification I want you to focus on. They're perpendicular, because they intersect at a 90-degree angle. But yeah, that's what perpendicular means. Okay, same thing with parallel, all right? You're not the only one. I'm so glad you brought that up. You were not the only one, you won't be the last, all right? I want us to focus on the other justification. If you want, you can say the lines do not intersect, but it has to be an addition. By definition, as soon as you say parallel, the definition of parallel is the lines don't intersect. All right, so you can say that just to keep confirming for yourself. All right, but that should be in addition to the same slopes, not the justification of. All right, find the intersection of the two graphs. All right, identify if they are parallel, perpendicular, or neither. In both cases, what do we need to do? What should we do first?
Solve for Y.
Solve for Y. And then a little note, when you end up with negative Y, don't forget to divide by -1 because it has to be positive Y when we solve this. Actually, let's do one more step here. So -x plus 6 divided by 3. Remember that becomes -x divided by 3 plus 6 divided by 3. It goes into both pieces. When we simplify this last step right here,
Would it be -3?
go ahead.
Would it be -3x?
X is in the numerator.
Oh, it'd be -1/3.
-1/3x to match it to how we typically write the slope. Remember that the value in the numerator can always come down. This is such a big deal. All right, and I see it constantly, x/5. All right, that's the same as 1/5 x. All right, same thing with any number. All right, that value being multiplied, remember this is technically 1/5 times x/1. All right, we can write this, but fractions, something about pulling stuff out of the numerator and putting it behind, all right? That people struggle with that. Be careful when you pull it out, that it doesn't all of a sudden end up in the denominator. X/5 is not the same as 1/5x. Okay, and then plus 2. All right, so let's graph these, see if we can get a visual on what we're looking at. So 0, -8. With a slope of 3/1. And our red line, y-intercept at 0, 2. Is everyone getting familiar with graphing, right? Slope-intercept form, always start, right, with your y-intercept, then just count it. What's the slope of our red line? -1/3. So down 1/3, down 1/3.
Intersect at 340.
They intersect where?
31.
They intersect at 3,1, absolutely correct, all right? Which is also why it's important, notice that when we draw the multiple lines way too often, all right? More than 1 point, because if I had just graphed 1 point, then like this one wouldn't even have touched this one, okay? I see it, oh, there's 2 points, oh, there's the line, there one, doesn't even look like it intersects, all right? Lines all the way through your graphs, it's not that hard, doesn't take that much longer, all right? Nice, beautiful graphs. And this one, I don't need to do the algebra. We're gonna do the algebra to confirm, okay? But I'm pretty sure that that's where they intersect. Let's do the algebra to confirm. Set y's equal. So our first line, 3x minus 8. So I have my two equations. With this one, all right, I have fractions, so what do we like to do? And actually, it's a good time to refresh on this one more time. Multiply everything by the reciprocal. Multiply the left side, multiply the right side, all right? What is the common denominator here? 3. So actually, that's pretty good. This one, all right, this is the technique we talked about the very first day, all right? It keeps coming back, all right? We're gonna get into it a lot week after next too. Once we're here, now the good news is there's not a ton to do here. Cancel, cancel, 1, 1, all right? All fractions are gone, really only took 1 step. Writing that value out, that 3/1 goes into every single piece, right? And then I just turned everything else into a fraction so everything would line up nicely. But that 3/1, all right, it gets worse for 1 step and then is about to get a lot better. 3 times 3x, 9x. 3 times 8, 24. 1 times x, negative x.
Isn't that -8?
Yeah, on the top or.
The top
on
is
the
negative
first
8. Oh, yeah, so it would be negative.
Because you did
24.
that.
Never mind.
I pulled so when I first wrote it, this negative, like I wrote the negative in front.
Oh, okay, that makes sense.
You can write it as, but the big thing is to signify their separation. If you have the -8 here, make sure this is a plus. Because these signs, notice, all right, that separates these two, the equality, negative, plus. Each piece is separated by either an equality or an addition or subtraction. Otherwise, it kind of looks like multiplication. That's why I have it written like this. All right, and then lastly, 3 times 2, 6. And oh look, fractions are all gone, easy peasy. Plus x, plus 24, plus 24. X equals 3. And then plug x equals 3 into 1 for both equations. 9 minus 8 equals 1. Negative 1/3 times 3 makes -1 plus 2. Oh, look, 1 in both cases. They should always come out the same, verifying. Now, be aware, it's really nice when they all come out as integers, right? Real numbers never come out nice, okay? So we deal with a lot of nice numbers, all right? But be careful. They're often not nice. All right, lastly. Are the lines parallel, perpendicular, or neither? Neither? They're definitely not parallel, right? So they're perpendicular because why? Not because 90 degrees. That is the definition of perpendicular. It is a good reason. Does anyone have a protractor to measure the angle? That's the only way you say they are perpendicular, because they are 90 degrees. They have a corner?
The negative reciprocal.
They're negative reciprocal slopes. 3/1, -1/3.
On tests, please don't judge how I spell reciprocals, because apparently I spell it wrong every time.
No problem. Not a spelling test. All right. Everything that is the end. All right, lots of good stuff. As always, there is a wonderful activity. All right, chapter 3, activity 3, and then relates directly to what we did today. And then chapter 3, activity 4 is kind of a summary of everything we did. Okay, so that way it has some questions. It's not just today, it pulls back.